You guys were asked to look at the questions on this page. Tony, can you read number 2 for us?
Observe the behavior of each function on either side of the zero using the tables and graphs.
Can you read A for us?
Describe the behavior of a function of odd degree on either side of the zero.
So let's look back at our table of values for the odd degree. Tony, is that the left or the right table?
Left table.
And what's happening on one side of the zero? What are these numbers you're seeing?
Fraction? Wait, I said negative.
Negative. And then what's happening as you go down?
It gets positive.
Positive. So negative to positive. Starts negative. Ends positive. We don't have a picture in front of us, but Tony, when you go from negative to positive, is that increasing or decreasing?
Increasing.
Increasing. I have seen my bank account one time go from negative values to positive. Thank you, Tony. Cecilia, can you read B? Let's go to even over here. It's this one. So, what do you notice about the numbers, really? So they go from positive to 0, and then where? To down here. What? Yeah. So positive to 0 to positive. Let's write that. So, Cecilia, we could say starts what? Okay, let's draw a picture of that. And yesterday we learned, class, that the graphs go from which direction? Left to right, right to left, left to right. So pretend you're on a roller coaster. You're starting here. Where would you go on the roller coaster? Would you go up or down? It's going left to right, you're going down. What word is down, class? This side would be the decreasing. The values, the y values are decreasing. And then you get to the part here, you're probably not happy because then what happens? You go back up, which is increasing. So decreasing, we go from left to right. And then increasing, y values are going up. Okay? Okay, now for question number 3, read for us Melissa C. The word flatten is what we learned about yesterday. You guys remember these graphs? And as the degree is going up, you'll look at 1, 3, 4, no, can't count. 1, 3, 5, so the odds. What do you notice about what's happening in here? I'm sorry? Yeah, and what's happening around the origin? It's getting more flat. So, question. Do you know why it's getting more flat? Now let's look to the table of values. What do you notice around the origin that Tina pointed us to? What do you guys notice about those numbers? Whole numbers or fractions? Fractions. Let's write that. Slow increase, decrease, because of fractions. Here's my real life example, and this will be your project very soon. Money. You guys might kind of sound silly. Oh, I just showed a picture. This is baby Autumn. Where's baby?
Zeros in my bank account.
So it's kind of silly. I'm a math teacher, right? I kind of know math. I'm not great at money. But I realized if I start a college account for her now, and she's only 6 months old, guess what happens when she's 18?
Big billions.
That bank account might be worth something. Now, what happens if I just put in like 50 cents?
It's not gonna do nothing.
It's not going to do anything. I can't even pay for a textbook, right? Your textbooks are going to cost $1,000 in 18 years.
$150 for like a textbook.
Now, what happens if I say, you know what? Oh, Mr. Ng saw a bonus. Put in $25 a month for the first 6 months, and they'll give me a $100 bonus. Do you think that now is going to be worth something? Yeah. So over here, why is it a steeper or a faster increase? So we can say fast, increase, decrease, because it doesn't have fractions. You have what? Whole numbers. If I put in like $20, maybe grandma's really nice and said, here's $100. You're going to have a faster increasing or decreasing. Because really the big idea from yesterday's lesson is it's called the power function, right? You want things to exponentially grow. So as Tina pointed out, fractions near the origin are flat because you're just putting in like quarters, 50 cents, not much. But if you put in like whole dollars, like $500, in 18 years with time and interest, that's going to grow really fast.